So for the first one here, well, for example 4 here, we are subtracting. It's really no different. You need the common denominator just the same. Only difference is when you get to the part where you can subtract, once you have the common denominator, you're going to subtract. Let's look at an example here. Find the least common denominator. In this case, it ended up being x minus 8 times x plus 2 times x plus 4. Again, we found that by factoring both denominators. Had to multiply both fractions by something to get the least common denominator to work. All right. Combine those like terms in the denominator. Notice how we put what you're subtracting in parentheses because you're subtracting each part of it. All right, that's important. You end up with 12x plus 12. That gets factored into 12 times x plus 1. Doesn't share anything, so there's nothing else to eliminate. And your answer is 12 times x plus 1 times x minus 8 times x plus 2 times x plus 4. All right, so let's take a look. We've got 2 to try here, so let's try them together. Pause it and try them and then come back and check. So for part A here, we determined that the least common denominator is 6x squared. Between 3x, 6x, and x squared, the coefficient's got to be 6, and the x has to be x squared. And we took each of the fractions and figured out, well, what do I need to multiply the denominator by to make it 6x squared? Do that in numerator and denominator, so you end up with 2x over 6x squared. Here you end up with x over 6x squared. And here you end up with 6 over 6x squared. When you combine like terms, you get 3x minus 6. That can be factored by taking a 3 out as a GCF. Between the 3 and the 6, you can divide a 3 away. So you end up with x minus 2 over 2x squared. All right, let's look at part B. All right, so here, the one denominator, I factored into x plus 5 times x minus 5. That becomes the least common denominator because the other one just has the x plus 5. So the first fraction can remain what it is. The other fraction needs the x minus 5 to get the denominator to be the common. So once you multiply the negative 2 in, you get negative 2x and you get plus 10. If you do it that way, the negative becomes just part of it. If you do 2x minus 10, then you're subtracting 2x minus 10, you get the negative 2x plus 10. Either way. Combine the like terms, you get x plus 5 over x plus 5 times x minus 5. In this case, the x plus 5s can cancel out. It's as if the x plus 5 in the numerator is its own term, and that would cancel out the x plus 5 in the denominator. So you're left with 1 over x minus 5. Let's look at the last example.